Hey folks! Have I got a whopper of a video for you today? Not only are we going to dive into this research paper, I am going to also give you a tour of the GitHub repository that I have built out specifically to recreate the results of this particular research paper. If you pay any attention to this channel at all, I make a lot of videos about AI agents. If there is a next step of artificial intelligence in my eyes, it is agents. Once artificial intelligence can be made to start being able to perform functions autonomously, the sky is the limit from there. It is a persistent problem though, as it remains an elusive nut to crack. In this video, we will first review the research paper titled, Small LLMs are Weak Tool Learners, a Multi-LLM Agent. Then we will dive deeper into the method outlined in this research paper and examine why it is different than other previously proposed methods, before finally taking a look at the multi-agent LLM GitHub repository. Settle in, the present is about to get a lot more futuristic. Let's begin by cracking open this research paper so we can see what's cooking. As the title suggests, the authors are challenging the assumption that smaller LLMs are incapable of mastering tool use. They propose a novel approach they call the AlphaUMI framework, which leverages a multi-LLM agent architecture to tackle this challenge. What's different about this framework? Here's where it gets interesting. Instead of relying on a single, monolithic LLM, this framework breaks down the task of tool use into specialized subtasks, each handled by a dedicated, smaller LLM. Think of it like a team of experts, each focusing on their specific skill. We have Planner. This LLM figures out the overall strategy for using the tool and breaks it down into actionable steps. Caller. This LLM actually interacts with the tool, sending commands and fetching results. Summarizer. This LLM takes the raw output from the tool and translates it into a human-understandable summary. Why is this better? The authors argue that this modular approach has several advantages. Efficiency. Smaller LLMs are faster to train and require less computational resources. Specialization. Each LLM can hone its skills for its specific task, leading to better performance. Adaptability. Individual LLMs can be easily updated or replaced without affecting the entire system. Intrigued? Let's explore the multi-agent LLM GitHub repo. Now, I wouldn't be me if I didn't dive into the practical side of things. That's why I built the multi-agent LLM GitHub repository. Here, you can access the code, see the framework implemented in TensorFlow. Run your own experiments, replicate the results of the paper and explore different configurations. Contribute and collaborate, join the community, and help push the boundaries of multi-agent AI. The future of AI agents? This research paper and the framework represent a significant step towards more capable and flexible AI agents. By leveraging the strengths of smaller, specialized LLMs, we can unlock new possibilities for tool use, autonomous decision-making, and ultimately, a more intelligent future.
Remember Gorilla LLM and the excitement around fine-tuning them as pure function calling machines? Well, the hype might have been a bit premature. These models, while promising, often stumble when the task demands more than just a single function call. Why the stumble? The culprit? A double whammy: low parameter counts and the need for sequential, multi-step logic. Imagine a tiny chef trying to whip up a complex dish. They might have the ingredients, but mastering the recipe's intricate steps can be a challenge. Previous models struggled with this. They were like chefs with limited kitchen tools and shaky recipe knowledge. They could handle simple tasks, but anything requiring multiple, distinct steps left them floundering. But fear not, a new hero has emerged. The framework in the Small LLM Are Weak Tool Learners paper presents a unique solution. Instead of forcing one tiny chef to handle everything, it creates a multi-chef team, each specializing in a specific task. Meet the team. Planner. This chef maps out the overall recipe, breaking it down into bite-sized steps. Think of it as the sous chef, outlining the order of operations. Caller. This chef interacts with the tools, fetching ingredients and performing specific actions. Imagine them grabbing the pans and chopping the vegetables. Summarizer. This chef takes the raw output and presents it in a beautiful, digestible dish. Think of them plating the final masterpiece. The magic is in the specialization. Each chef, represented by a very small parameter model, focuses on their specific task, honing their skills to perfection. This modular approach overcomes the limitations of previous models, allowing them to tackle complex, multi-step tasks with ease. It's like having a team of experts in your kitchen, each contributing their unique talents to create a culinary masterpiece. So, the next time you encounter a task that requires more than just a simple function call, remember the power of the multi-chef team. This is just the beginning, folks. The future of AI is filled with possibilities, and the small LLM framework is a delicious step in the right direction.
Calling all AI enthusiasts and code wranglers, brace yourselves for a groundbreaking release that's about to redefine how we approach complex tasks with AI. I'm talking about the Multi-Agent LLM, an open-source repository that's bringing the power of multi-agent learning to your fingertips. This project is a faithful recreation of the small LLMs are weak tool learners, a multi-LLM agent research paper, and it's poised to change the game. Here's a quick rundown of what's inside this mind-blowing repository. First, we have the Multi-Agent LLM methodology overview. This section dives into the framework's core components, the planner, caller, and summarizer agents. Each agent plays a unique role, working together in harmony to tackle complex tool-using tasks. Think of them as a crack team of specialists, each with their own expertise. The planner maps out the strategy. The caller interacts with tools, and the summarizer presents the results in a clear, concise way. Next, we explore the innovative global-to-local progressive fine-tuning strategy. This two-stage approach ensures that each agent is perfectly honed for its specific role, starting with a global fine-tuning on large datasets and then specializing through local fine-tuning on tailored subsets, ready to get your hands dirty. The Getting Started section walks you through the installation process and dependencies, so you can set up the framework in no time. And of course, the repository includes datasets from the research paper and Gorilla release, as well as code for generating synthetic datasets to train your own powerful agents. This is just the beginning, folks. The Multi-Agent LLM framework unlocks an era of efficient and adaptable AI. I can't wait to see what you create with it. Head over to the GitHub repository now to dive into the code, contribute to the project, and join a community of passionate AI explorers. Together, let's push the boundaries of what's possible with multi-agent learning.